Our next discussion is going to be on multiplying and dividing decimals. So if we're looking at something like 0.2 times 0.03, we want to see how that process works. Now I just want to try to give you some justification as to why we use the technique that we use. 0.2 is 2/10, or if you like, 2 times 1/10. 0.03 is 3/100, or if you like, 3 times 1/100. Now, using the properties of multiplication, we can reorder these things and write it as 2 times 3 times 1/10 times 1/100. 2 times 3 is 6. A tenth times 100th is 1,000. So 6/1000ths as a decimal, 0/10, 0/100, 6/1000. That's how we can kind of think our way through that process. But the way that it's typically taught is as follows. 0.2, 0.03. The numbers that we have are just 2 times 3. If we multiply those together, we get 6. Then we have to count the total number of decimal points to the right. So in this case, we have 1, 2, 3. There's a total of 3 decimal places that we need to account for, namely thousandths. So we've got to move the decimal place, or put the decimal place 3 points to the left as we do this, and the result again would be 0.006. Let's take a look at something like this. How about 2.1 times 1.342. The total number of decimal places, 1, 2, 3, 4 decimal places. We'll keep that in mind. That's what we're working off of. So we've got to take 2.1 times 1.342. So I'm going to multiply those without concern for the decimal places, and I will adjust those at the end of the discussion. So we have 1, 3, 4, 2 times 2, 1. Writing the larger number in terms of numerals on top and the smaller number in terms of numerals on the bottom. That is, 1342 has 4 numerals, 21 has 2 numerals. It's just a little simpler to do the multiplication this way. So do multiplication as you typically do. 1 times 2 is 2, 1 times 4 is 4, 1 times 3 is 3, 1 times 1 is 1. Move over 1 unit. I'm going to put an X in that slot. 2 times 2 is 4, 2 times 4 is 8, 2 times 3 is 6, 2 times 1 is 2. And what does that become? You get 2, 8, 11, carry a 1, 6, 7, 8, 2. So without regard to the decimals, we get 2, 8, 1, 8, 2. But as we saw earlier, there were a total of 4 decimal places that we needed to consider. So our final answer must have 4 decimal places. So it's 2.8182. You will see moving it to that spot, 4 in, that will have 4 decimal places, and it'll go ahead and give us our solution. So let's do one more in that vein. So if we have 7 times 0.35, well again, we're going to ignore the decimals, only count them. There's a total of 1, 2, 2 decimal places. 7 doesn't have any. So we're going to write it down as 35 times 7, 35 times 7, doing the multiplication, ignoring the decimals. 7 times 5 is 35, carry the 3. 7 times 3 is 21, and 3 more is 24. But the question says we have to have 2 decimal places, so we write 245, recognizing we have to have 2 decimal places, count over 1, 2 decimal places to the left, and we get 2.45. For that answer. Okay, the next thing we're going to look at is division. And if I have something like 6 divided by 0.02, let's ask ourselves what that means. Well, in health sciences, and frankly in most areas of mathematics, we like to think of division in terms of fractions. So 6 divided by 0.02 can be written as a fraction, 6 over 0.02. And as you know, we would rather, or we can multiply top and bottom by the same number, multiply by a 1. And I'm going to multiply the top by 100, I'm going to multiply the bottom by 100. So that 6 times 100 is 600. 2 hundredths times 100 would just give us 2. And then 600 divided by 2 is 300. So conceptually, that's what's happening with division of decimals. Now let me show you the strategy you most likely were taught in school. 0.02 into 6, using the long division symbol. 6 doesn't have a decimal point, so we can give it 1. Now it's not 0.6. 0.6 is 6/10. 6 is 6 point. Now how many decimal places do I have to give it, or how many zeros can I put in? 0/10, 0 hundredths, 0 thousandths, 0 10,000ths. You can put as many in as you'd like. Now, the standard method taught in school is to move the decimal point to the end of the divisor, the number on the outside. So you'll notice that was moved 2 places, so I would move this one 2 places. But in college, I would hope to think that we could understand why that works, and I hope you notice that in essence what happened was we multiplied the top of the fraction by 100 and the bottom of the fraction by 100. So this now is 2 into 600, which of course 3 times 2 is 6, 2 into 0 is 0, 2 into 0 is 0, and we get 300. So let's do one more of the division problems to get a feel for how those behave. What if we have a simple question like this? How about 1 divided by 3? So that would mean 3 into 1, and let's give ourselves a whole bunch of decimal places to get a feel for how that works. Now this time we don't have to move any decimals, but our answer is going to be a decimal. We'll move the decimal point up there. 3 into 1, 0 times. 3 into 10, 3 times. 3 times 3 is 9. 3 into 10, 3 times. 3 times 3 is 9. 3 into 10, 3 times. 3 times 3 is 9. And you'll notice that pattern continues forever. So this is a repeating decimal. And we can say 1 divided by 3, which is the same, of course, as 1 over 3, is simply 0.333 repeating. Sometimes we use the symbol 0.3 with a hat on it to demonstrate that we have a repeating decimal. Let's go ahead and do one more division problem. Let's try 14.7 divided by 0.06. So we're going to make a question where he's taking 0.06 into 14.7. Move the decimal place, which means multiply this by 100. Multiply the denominator by 100. Move this 2 place. Multiply the top by 100. You'll notice there is no 0 there to see, so I've got to put 1 in there. So the ending place of the decimal point is there. So this in essence becomes 6 into 1,470. 6 into 14 twice. 2 times 6 is 12. 6 into 27 4 times. 4 times 6 is 24. 6 into 35 times. 5 times 6 is 30. So our answer to this becomes 245. And it's kind of nice because we don't have any decimals in the final answer. Certainly it's quite possible, if not probable, when you are doing decimal division, that your answer will also be a decimal. That will conclude this exercise set.